Hi everyone, my name is Ayşe Irmak Ceylan. I'm second year computer science student at Bilkent University. For my Physics 101 project, I designed an experiment, and the aim of this experiment is to investigate fundamental principle of rotational dynamics by examining the relationship between torque, angular acceleration, and moment of inertia. To explore this, in this experiment, I used a rotational dynamic apparatus in which a small hanging mass is attached to the string wrapped around the torque pulley. When this mass is released, it creates a torque that causes the attached disc to rotate. The optical sensor on this apparatus measures the number of lines passing per second, which I denoted as N, the capital N, in my calculations. And I used this value to calculate the angular velocity of disk using the equation that omega, the angular velocity, equals to 2 pi over 200 multiplied by n, the number of lines. And by recording angular velocity values at 1 second intervals, I drove the angular velocity versus time graphs and determined the angular acceleration from their slopes. Using these results, I calculated the experimental moment of inertia and compared it with the theoretical values for two different disks, steel and aluminum disks. In conclusion, the experiment successfully demonstrated the relationship between torque and angular acceleration, supporting the equation torque equals to moment of inertia multiplied by angular acceleration for rotational motion. My data showed that increasing the hanging mass results in a greater applied torque and consequently higher angular acceleration. Additionally, I observed that the steel disc, having a greater mass, showed a larger moment of inertia compared to the aluminum disc, which results in a lower acceleration under the same applied torque. The overall trend in my results matched the theoretical expectations, but there were some differences between the experimental and the theoretical values of the moment of inertia. These differences are likely due to factors such as friction in the system, air resistance, and small inconsistencies when releasing the disk. Even with these differences, the experiment clearly showed that how rotational motion works and demonstrate that the moment of inertia has a direct effect on how a system responds to an applied torque. So this was my experiment and its results for the Physics 101 project. Thanks for listening.